Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 1.6, representing functions as rules. Okay? As always, if you have not tried the warm-up, please pause the video and do that yourself before you come back and check it over. For exercises 1 through 3, write a mathematical expression for each. So the first one says 2/3 of a number x, so that's going to be 2/3 times x. Of usually means multiply in math, and in order for something to get smaller, we're going to times it by 2/3, and that will shrink it to 2/3 of it. Okay. The sum of 2 and the square of a number r. So the sum translates into an answer to an addition problem. So we go forward and find and, replace that with a plus. On one side of the and was the 2, and on the other side was the square of a number r. So we write r squared. Each person's share of baseball cards if 4 people share C cards equally. So it's not you and 4 others this time, it's just 4 people. So we take the C cards and we divide it by 4. And if this didn't come out evenly, then we'd have to tear up some cards in order to divide it equally. Okay. Number 4, was the expression correctly using the order of operations evaluated correctly? And the answer to this is no. Okay. If not, find and correct the error. So the error here was they did this multiply 1/3 times 15 to get 5, and they skipped over the order of operations, which would say do exponent first. So correcting the error would be something like this: 8 minus 1/3 times 225, okay, which turns into 80 minus 75, and then that equals 5. Number 5. Match each exercise with its label, A, B, or C. So we are trying to figure out which one of these are expressions, equations, or inequalities. So an expression just has numbers, variables, and operators. None of those equals or less than symbols. So that's part number 3 here. Okay. An equation should be 2 expressions separated by an equal sign. That's number 1, so this would be choice. Equation is choice B. Okay, and then the last one here, inequality, is 2 expressions separated by either less than or equal to, greater than equal to, or even a not equal to, something that does not show equality. So this would be choice C here for number 2. Okay. Before you can tell how much Mr. Elliott paid for his gas at the Esso station, what must you know? Now, you might think you need to know what's the cost of the gas, but you can figure that out without asking Mr. Elliott anything. You could just stop by the Esso station or call the Esso station and ask how much it was on that day. Okay, but you do need to ask Mr. Elliott something. You need to ask him, how many gallons did he pump? Okay. And that is important. So how many gallons did Mr. Elliott pump? All right, so when you pump gas, the total cost depends on the number of gallons, and that's because the total cost is a function of the number of gallons pumped. The total cost here, this is our outputs, and this is our inputs. A function is always written like this. The output is a function of the input, okay? So here's the definition of a function here. A function is a set of called the domain that contains all of the inputs. So it's a list of numbers that are in the inputs. It also has a set called the range, or a list of numbers called the outputs. And then it has a pairing of inputs and outputs such that each input is paired with exactly one output. For instance, the input of 10 gallons pumped should not be paired with 2 different outputs, 19.99 and 39.99. Now, why is that? Well, that makes sense because if 2 people went up to the gas station at the same time, they both pumped this input of 10 gallons, their output for cost should not be different. We walk in and they say, oh, you pay 19.99, you pay 39.99. That just doesn't make any sense. So for it to be a function, every input can only point to one output. Okay? All right, so down below here is an input-output table for the various amounts of money paid for pumping gas. So we have these inputs, 10, 12, 13, and 17. and we have these outputs, $19.99, $23.99, $25.99, and $33.98. So these inputs up above made the outputs down below. So our first question says, what is the domain of the function? Remember, the domain is the list of inputs. So that's the 10, 12, 13, and 17. And the range is the list of outputs. So that's the 19.99. That's the 23.99. That's the 25.99. And that's the 33.98. Okay? Number 4. The input-output table shows temperatures over various increments of the time. So you can think of this as maybe something like 6 a.m. when you wake up. That's time 0. This is 2 hours later at 8 a.m. and this would be like 6 hours later at noon. Okay? So usually temperature rises as the day goes on because the sun helps warm things up. So here we're asked to identify the domain and the range of the function. So once again, the domain are the inputs, 0, 2, 4, and 6. And the range are the list of outputs, 24, 27, 30, and 33. So if I am fast on the notes, it's to save time. So what you need to remember is that you can pause to write in the things that you need or back up to re-listen for stuff. Okay? All right. Making a mapping diagram for the information in the function table. So we want to make a mapping diagram. A mapping diagram consists of the list of inputs inside a bubble and the list of outputs inside a bubble. And then once we list our inputs, 0, 1, 2, 4, and we list our outputs, 5, 2, and 1. Notice there are 2 2s in our output list, but I only put it in here once. Okay? And that's because for an input-output diagram, we just connect. And if we have the same thing in there twice, it would be confusing. So our 0 connects to 5. Our 1 connects to 2. Our 2 connects to 2. And our 4 connects to 1. All right? Now, if you were thinking before, oh, look, back up here, Mr. Ellett said, hey, and this thing here, pairing of inputs and outputs shows that each input is paired with exactly one output. And he said my inputs, they could only point to one output. So this guy down here is probably not a function. But it is a function because it doesn't say anything about the 2 different inputs pointing to the same output. That is allowed. Okay? So you could think of it as something like this. Hey, if you got 0 things wrong today in class, maybe you earned 5 points for your table. If you got 1 thing wrong, you got 2 points for your table. If you got 2 things wrong, you also get 2 points for your table. It's okay for 2 inputs to point to the same output. Okay? All right. Flip it over. Tell whether each pairing is a function and explain your reasoning. So the definition of function is the input contains a list of numbers. We have a domain here and a range that contains a list of numbers, and such that each value in our domain points to only one value in our range. So 4 only points to 1, 8 only points to 2, and 2 only points to 3. So yes, this is a function. Okay. Part B, we do have a list of inputs called the domain. We have a list of outputs called the range, but we have a problem here. Input 2 is in here twice, and it points to 2 different things. Sometimes 2 makes 2, and sometimes 2 makes 4. So no, this is not a function. Okay. The input 2 maps to 2 different outputs. And I think this is usually the trickiest thing for this lesson, telling whether something is a function or not. All right, so down here for number 7, we have to tell whether the pairing is a function. And once again, this is not a function because one of these inputs points to 2 different outputs. So we do have a domain, a list of inputs. We do have a range, a list of outputs. But our problem is here, 5 points to 3, and it also points to 4. Okay, and that's not allowed. All right, a little bit more about functions. A function may be represented using a rule that relates one variable to another. So it's kind of like a formula. Okay, and it relates the input variable, called the independent variable, to the output variable, called the dependent variable. These names for independent and dependent variable make sense. You can think of them in terms, once again, of our gas problem. We had inputs and we have outputs. Our inputs were gallons pumped, and our outputs were the cost, right? I don't remember what this one cost. So this is the independent, and this one was the dependent. And that was because I get to go up to the pump, and I get to pump whatever I feel like. It's independent. I can choose. But once I've pumped, when I go inside my outputs here, they charge based upon, these outputs depend upon how much I pumped. So I pay my output depending upon what I pumped for my input. So my output is dependent upon the inputs that were picked. Okay. All right, so for number 8 and 9, we're asked to make a table for each rule. So we're going backwards here, and we're given a domain, and we're asked to find the range for that particular domain. So here's our table. We have our input variable and our output variable. So remember, this is the independent one. We get to pick whatever we feel like here, but once we pick it for x, we plug it into our rule or our formula, and we get our dependent variables, or the output part. Okay. All right, so our domain, our inputs were picked for us in the problem, though. Okay. And then the dependent variable is found by, or dependent variable values are found by plugging in the inputs. So 4 times 1 minus 2 will give me 2. If I plug 2 in for x, 4 times 2 will give me 8. 8 minus 2 is 6. You plug 3 in, you get 10. And if you plug 4 in, you get 14. Okay, and then it asked us to define the range, which is the values of the dependent variable. And these values are going to be 2, 6, 10, and 14. All right, and then in our last one here, number 9, okay, we are giving the domain of 10, 20, 30, and 40. So those are our inputs. And we find our outputs by plugging them into our rule or our formula. So if I plug 10 in and times it by 0.1, timesing by 1 does not change the number, but timesing by 0.1 doesn't change the number only by moving the decimal 1 time to the left. So this will be 1 plus 3 for 4. I move the 20 decimal 1 place to the left, I get 2. 2 plus 3 would be 5. Then 3 plus 3 for 6, and 4 plus 3 for 7. Okay. So our range is the list of outputs again. So 4, 5, 6, and 7. Okay. On the last page, we're going in reverse of that. So we got the table we want to make the rule. Okay. So we have our dependent variable, that's our output. We have our independent variable, that's our inputs. And when we plug in 1, we're supposed to get 5. If we plug in 2, we get 10, 3, 15. So this looks like I take every input and I times by 5. So I take my input variable, times it by 5, and I get my output variable. Okay. All right, number 11, one more time. We have our independent variable, x. We have our dependent variable, y. And we need a rule to go between them. So what do we do to each of these values in our domain is we subtract 7. So that means I can take x and subtract 7. My independent variable, subtract 7, will give me my dependent variable. All right. We have 2 more here. This time we're talking about shoe sizes between US and Australia. So write a rule for Australian size as a function of the US size. So this, remember, is output compared to input, or output is also our dependent variable, and input is also our independent variable. All right, so that means our US sizes, which are our inputs here, are going to go on this side, and our Australian sizes, which are our outputs, are going to go on this side, okay? Because Australian is the output. And what we do for each one of these is just subtract 2. So this is going to be the US size minus 2 will give you the Australian size. All right, number 13, balloon bunches. You are making balloon bunches to attach to tables for a charity event. You plan on using 8 balloons in every bunch. Write a rule for the total number of balloons used as a function of the number of bunches. So total number of balloons is our output as a function of the number of bunches. This is our input. So total balloons is equal to some function of our bunches. Okay? And we take 8 balloons for every bunch, so we would have to times this by 8 to get it to work. Be careful, don't put add 8. If you add 8 and you made 8 bunches, then that'd be 8 plus 8 for the total balloons. That doesn't make sense. It's got to be 8 times 8. Okay? All right, now it says identify the independent and dependent variables. So the independent variable is always the input variable. So B is the independent one. I can decide how many bunches I want to make, but the total balloons, okay, is going to be dependent upon that, how many bunches I was making. Okay, so that's the dependent variable. And then we said use our rule to figure out how many balloons you will use if you make 10 bunches. So to use our rule for this, we replace B with 10, okay, and then we multiply it together. 10 times 8 will give us 80 bunches. So we replace B with 10 here, okay? So 80, I'm sorry, not 80 bunches, but 80 total balloons. 80 total balloons for 10 bunches. Okay, this concludes our notes for today. I'll see you in class next time as we practice and extend this lesson.